I think the only way to understand it is to get outside the universe. We're in California, it's easy to do that here. But let me do it this way. Here's a universe that's two-dimensional and that you can stand outside of. And here's, I've put the galaxies at nice uniform distances here. And again here, and you can see at a later time the universe is bigger. The galaxies are a little bit further apart. So if you were standing outside of that universe, it would be obvious that it was expanding uniformly in all directions. Now, what would you see if you were on that universe? Well, just pick a galaxy, any galaxy. And the way we could figure out what you'd see from that galaxy is to superimpose this image on top of this one, placing this galaxy on top of itself. Okay, what do you see? You see precisely what Hubble saw. Every galaxy is moving away from this galaxy. Those that are twice as far away have moved twice the distance in the same time. Those that are 3 times as far away have moved 3 times the distance. And it doesn't matter which galaxy you're on. Everywhere you see the same thing. Everywhere you think you're the center of the universe. So depending upon your mood, either every place is the center of the universe or no place is the center of the universe. It doesn't matter. The universe is expanding. And that really did change everything. And by the way, it had profound religious implications, at least. As some of you may know, that in response to this and other things, the Pope at the time gave an encyclical that science had proved Genesis. And the interesting person, the first person to actually show there had to be a Big Bang, was a Belgian priest who was also a physicist named Georges Lemaitre. And the really interesting thing about Lemaitre is when the Pope said that, Lemaitre wrote him a letter and said, "Stop saying that." Just really amazing for a priest, because he said this is a scientific theory. You can take it if you believe in God and believe in Genesis to validate your beliefs. But you can also take it to mean that, in fact, the laws of physics take us right back to the beginning of time without God. What you take from it depends upon your religious and metaphysical beliefs, but whatever you say, the Big Bang happened. And I think that's if we could just convince a lot of people of just that simple thing, that the universe is the way it is, whether we like it or not, I think we'd overcome a lot of problems in this country, and I have to waste far too much time on that. But anyway, okay, but this is a science talk, although I'll throw in little bits of commentary throughout, I suppose. How do we know the universe is expanding? It's such an important thing, I want to spend a few minutes on that. Well, we do, as these two guys on the plane out there near Arizona say to one another, "I love hearing that lonesome wail of the train whistle as the magnitude of the frequency of the wave changes due to the Doppler effect." Now, what they're pointing out is that when a train comes towards you, the train whistle sounds higher. When a train moves away from you, the train whistle sounds lower. And that same principle was used by Hubble and others. The same is true for light, for very different reasons. So when we look at distant galaxies, if they're moving away from us, the light, which is a wave, gets stretched out. The longer wavelength part of light, or the red end of the spectrum, so it's called redshifted. And galaxies are more and more redshifted the further and further they are away from us. So that's how we know their velocity. The velocity is easy. How do you know distance? That's really hard. The universe is a big place. And we don't have tape measures that are that big. We have to find a way of determining distance without actually going to a place, and that's hard. And in fact, one of the ways, well, of course, the way we do it is we use physics. We could determine the distance to the back of the room if I turned out all the lights and only one light was on and I knew it had a 100-watt light bulb by having an old-fashioned camera, which none of us have anymore, that had light meter on it. And if there were 100 watts there and I was receiving 1 watt of light here, I know how that light spreads out as 1 over the square of distance. And so I could determine by how much wattage I was receiving here, knowing the wattage of that light bulb, how far away it was. Okay? This undergraduate or high school physics exercise. The problem is the universe isn't full of 100-watt light bulbs. If it was, life would be easier. So we have to try and find the equivalent. We have to try and find what's called a standard candle. Something whose intrinsic brightness we understand, and therefore when we look at it through a telescope, we see how bright it appears through the telescope, and we work backwards to figure out how far it is. That's the hard part. That's why it's been so hard to determine the rate of expansion of the universe, because it's hard to find standard candles. This is Hubble's original data from 1929. And this is one of the reasons he was such a great scientist, because he knew to draw a straight line through this data set, which itself is already not so clear. It's not obviously the right answer. But what he found was, in fact, that velocity is proportional to distance. Okay? And the great thing is he got the answer wrong by a factor of 10. which was an embarrassment at the time. Again, I'll throw a little commentary in it. Because if the universe were expanding this fast, you could calculate its age, and its age would be 1.5 billion years old. That was in 1929. Now, as anyone knows, if you read any of Richard's books, you would know that, well, but by 1929, we already knew the Earth was older than 1.5 billion years old. And so it was embarrassing that the universe was younger than the Earth. One of the many embarrassments in cosmology that's happened over the years. And in fact, taken by some people to once again argue that science didn't know what it was doing. But the problem was, of course, he wasn't a bad astronomer, a bad scientist. The problem was trying to measure distance because he didn't have good standard candles. And that's, as I say, been the holy grail, if you wish, of cosmology over the last century. And we now have standard candles. Here's one. I wish there was better resolution on this projector. It's a beautiful picture from the Hubble Space Telescope of a distant galaxy, far, far away and long, long ago. And there's a whole galaxy. It's about 1 billion light years away. We're looking at it as it looked 1 billion years ago. So many of those stars no longer exist. And here's an object that's just as bright as the whole center of the galaxy. You'd think it's a star that's near in our galaxy that just got caught in the picture frame. It's not. It's a star on the edge of that galaxy that has exploded. And exploding stars shine with a brightness of 10 billion stars. They're the brightest fireworks in the universe, supernovae. And they're remarkable, and I keep having asides. Maybe I'll get to my point eventually. But this is something that I wrote a whole book about, and someone asked me yesterday why I wrote that book. Because it is the most poetic thing I know about the universe. Richard wrote a great book called, what's it called? Our Ancestors? What's it called? Ancestor's Tale, yes. I wanted to make sure I got that right. And I wrote a book that was a different Ancestor's Tale. It was called Adam. But the amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution weren't created at the beginning of time. They're created in the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today. Okay? And anyway, this is great. Anyway,